Right, base times height is the area of this first area right here. So it happens to be 1 meter, so yeah, it's 100, right, 150 newtons. And where is it located?
In the middle?
In the middle. So this is 0.5 meters. Okay, Hector, next. How about this triangular distributed load? How can we describe that? Let's call this F2. What's it equal to?
75.
Tell me how.
So it's 1/2 base times height.
1/2 base times height, and the base here is 150 and the height is 1, so it turns out to be 75 newtons. And where is it located?
A third.
I'm gonna do it from the A. Okay, so where is it located?
So it'll be 2/3.
Right, 2/3 of a meter. Any questions? Everybody good with that? Distributed loads on the exam looked good.
I just call it 0.3, so is it, you know,
0.3?
the distance, is that from the middle, from B, I did 0.3, is it okay that we shorten it down instead of calling it 1/3?
0.3, well, you tell me, you guys are the ones that are coming from math and physics and chem. I'm the one who's rounding everything. Is 0.3 good enough for you?
Yeah.
It sucks. It's not good, right? Because it's 1/3. I mean, you're off by,
0.03.
I think you're off significant amount. What do you guys think as a whole? If you, I mean, coming from that, I'm surprised that you guys won't want to carry it out 20 decimal places.
Because our physics teacher just said he marked us down after we went past.
Right, but 0.3, okay, so how many, I mean, seriously, are you guys okay with 0.3 representing a third?
No.
No, so put 0.3 and put a line over it or something, right? You're gonna make a rounding error, a big rounding error.
Shut down, Spencer.
Okay, we're up to Ivan, what do you have to find?
The tension between.
Right, that's all they want you to find, right, the tension. But we're gonna set up our table, so Daniel, give me some forces here.
Tension BD.
Say it again?
Tension.
Okay, and I'm not going to call it tension BD because I don't want to waste my time during the whole problem writing BD 20,000 times. I just want to write T, period. That's it. There's one T. Magnitude, you know it. Direction?
Yeah.
Okay, what else? Daniel, give me a couple more.
The normal from E, the load.
Okay, so normal, and it's going to be, so here, right in here is going to be my tension, and right here is going to be my normal. Do you know the value?
No.
No, direction.
Yeah.
Okay, next. Cameron, next.
The pin connection at A?
Okay, so we have a pin at A, so we have an AX and an AY, right?
Yeah.
Do we know them?
Nope.
Nope. But we know their direction. Another one, Cameron?
Pin at C?
Pin at C, so we have a CX, right, and a CY. Do we know them?
Nope.
No. Okay, and I have to continue over here. Force, moment, magnitude, direction. Kenzie?
I put force 1 and force 2.
Force 1 and force 2, so that's the 150 Newton and the 75 Newton. And we know both the magnitude and we know the directions, right? Anything else? Anybody write anything else?
That's okay, but
Just wait. Wait. The weight of what? There's no weight, it said, right?
the load of the
What load?
that's from force 1, force 2.
I don't understand. So instead of putting, would you just put F1 and F2 you're talking about?
No, just I have to put weight.
Okay, so they're definitely not weight, right? Because weight always goes down, right? We don't really know what this is. It's some kind of load coming from the side, right? So I don't know if it's wind or what it is. But so I wouldn't call it weight. But you can call it another variable. You don't have to call it F1 or F2. You can call it something else. But I wouldn't call it weight because it's not a weight. Wouldn't call it tension. It's not a tension. And I wouldn't call it normal because it's not a normal. It's something. Okay, a couple hands went up. Charlie, and then...
When you end up breaking it up though, aren't you going to get more forces?
Breaking up what?
You know, like the tension from the three-member bar or whatever.
Look, so I can see. What?
So when you break up the D, like the bar from the tension, in the book it has it where it adds dx dy and then TBD or whatever.
There's no, it's one bar. It's bar CDE, there's
So
there's no pin there, so there's no X or Y. I'm not gonna break
Oh.
the middle of the bar. Right, it's one bar, it's just held there. I don't know if it's a hole or if it's a screw or something, but it's bar CDE. Only if it was 2 bars. And that's why at the beginning when people asked questions, I said, the fact that I'm calling it number CDE means it's only 1 bar. Okay, you have a question? Danny, I'm sorry, I said Mason. Danny,
I just called it F.
called what?
150, like F1 and F2. I just called it F, and
And what, you call this F and what did you call this?
I just averaged the distances from y equals 0, and then
Okay.
added F1 to.
Okay, so what it sounds like Danny did is he took this the rectangular distributed load and the triangular and found the resultant of that, right? And finding the resultant is like finding an equivalent system, right? So you would have had to do some of the moments about A, and this force times this distance, plus F2 times this distance. You know that the sum of the forces is these two together, so it would be 225, and then you would have to do some of the forces, some of the moments divided by the resultant force to find a location. And if you did that, great, but it probably took a little more time than just leaving them separate. I'm not talking about that a lot because I think it takes time and it would be better to keep them separate, but what Danny did is he took these 2 loads and find the resultant and where it would act to create the same moment about A. And that's actually what you did on your exam too. You can do that, you just have to make sure that you're being detailed and you don't make a mistake. I think it would be better to just leave it as 1 load here and 1 load here because there's less math to make a mistake. Okay, but certainly you can do that. Okay, Kenzie, you said these guys, any other loads in here?
No.
No. And you had to go all the way, okay. Okay, great. Okay, what I thought you guys were gonna say is, well, what about this pin at E? We talked about this in class, and I just wanted to confirm that you were comfortable with that. So, Eddie, could you describe? Why didn't you put an EX and an Y here?
It's a wheel.
Because there's a wheel and,
It does,
it's totally cool, because this is a hard thing. Stanley, do you know? Why don't you put EX and EY here? Okay, hang on, look at this. Remember when you have a load, you have a tension in a cable, and you have a weight on the bottom? Really what we should be doing is doing, can everybody see? We should be doing sum of the forces in the Y equals, the tension is going up, the tension minus W equals 0. And we know the tension is W. So early on in the class, we said, we are not going to do this equilibrium equation. We know that this weight is transferred through this tension, so we know the tension is equal to weight. We are not going to do this equilibrium equation. We're going to do it in our head. So that's a hint for the same thing here. What is this connection here? What is this? It's a pin. So it should have an X and a Y. But what do we know about the X component of that pin? It's 0. Because if I just analyze the wheel here, there would be an EX and an EY, and there would be a normal, and the normal would be equal to the EY. And I'm doing the same thing for this. I'm not going to bother doing equilibrium equations. I'm going to allow you to just do that in your head. So there's no need to write EX and EY on here because you know EY is the normal, and the normal just transfers directly to E. Okay, so this is the second time that I'm mentioning that. Malcolm?
So, in other words, EX and EY are internal forces to the whole wheel.
You really
part.
can't say that because,
Well,
hang on, just watch. If you have this piece and you have the wheel on it, that's all you are drawing is the normal, right? Because EX and EY are normal, are internal. So in that case, you're correct. But if I just draw the bar, that EX and EY is out now external because I took the wheel off it and it still only experiences normal because EY is equal to the normal. Did you get that? So if I draw the bar with the wheel, you're right in that the EX and EY is internal here because there's an EX and EY this way and there's an EX and EY here between the bar and the pulley, or this, what is this, wheel. But once I take the wheel off, that EX and EY becomes external, but I know when I draw this, if I draw a free body diagram of the wheel and I draw, let's say, EX this way, and we realize it's equal to 0, and I draw EY that way, I know that EY is equal to the normal, so that EY is like this. So, rather than getting into all the details of what's going on here, whenever we separate something from a normal, even if there's a wheel here, it just gets the normal. Charlie?
Well, yeah, okay.
Okay.
Do you want to call it Tues if you want?
Don't worry about the quiz now. I'll look at it when I see everybody what they wrote. Don't worry. Okay. Let's just use this as a learning experience. I mean, why do I put these things in the quizzes? So that you learn. It's another way of instructing. And also I get to see what things you're comfortable with and what you're not. Okay, where are we? Angelina, what's you? So how many unknowns are there total in all this? 6 unknowns. How many equations do you need then? 6 equations. But that's only if you have to find all the unknowns. The problem only says you have to find t. So now draw the free body diagrams. So Danny, let's do ABC. Tell me what's on ABC.
Oh, we've got AX and AY.
AX, AY.
And we've got T.
We got the t. In which way should I draw it?
To the right.
Great. And
And we've got CX and CY. And we got the force.
good. CX, wow, this one's loaded, huh? And this is, I'm now going to write numbers, 115 newtons. And I know this is 0.5 meters, right? I have to make sure that I have the distances. Okay, and what's the other one? I have the 75.
Ooh, further up.
Oh, thank you. The thick part is up above. And where is it?
Third.
3.
Great, thank you. Okay, Tim, how about CDE? What do I have?
CX and CY in the opposite direction.
Good.
Tension as well in the opposite direction.
Good.
And then normal E.
So I'll call this free body diagram 1, free body diagram 2. Okay, Marky.
You have AX and AY, and then you have the normal E.
Oh, right, and I'm going to keep that intact, right? It's the whole structure.
And then you have the forces.
And then the forces. Okay. Free body diagrams look good on the exam. Free body diagram, great. Okay, now talk to the person next to you to see what's the least number of equations.
2. Sorry. 2. Tim, what'd you do? How many? Dude, yes!
Little side pitch.
I didn't know that.
Almost there.
Some people can't.
From 10 to 11.
I like it. It keeps me warm. No,
No, hey, Matt, he works you.
yes.
So how did you do this?
I took free body diagram 3 and solved for AX using the forces in the X.
Okay, you guys went on, what equations do you like to do better? Do you like force equations or moment equations?
Forces.
Depends on the.
Okay, I'm thinking forces, that's what I would think you would say because they're easier, right? So always look first for the force equations. Some of you did the moment equations first on that second problem, and had you done the force equation first, you would have solved it quicker. Okay, so look at force equations first. Okay, sometimes you don't have what do I say? You have a choice. In order to get one unknown and one equation, you have to do a moment equation. But first look if there are any one equation with one unknown that's a force equation. Okay? Also, some of you saw, and I did not take off if you didn't do it most efficiently. But some of you solved, for number 2, you did 6 equations, 6 unknowns, you did it into a big matrix, and then all the answers are wrong because there was one math mistake. It was a negative instead of a positive or something. So I'm telling you, don't do all that. Don't do all the equations and shove them into a matrix. Try to look for the equation that has one unknown, that's the simplest, and then solve each way, because you're going to make less mistakes than if you have 6 complicated equations. Okay, force, free body diagram 3, sum of the forces in the X, got AX. What's the second thing, Matt?
Use free body diagram 1 and found the moment about C. Solve for T.
Okay. Anybody do it different? Another option. Alex, wait, hang on a second. Option 1. Okay, option 2. Okay, what's your way, Alex?
It's just the same as sim. It's just that you start with the moments about A, and then you solve the forces.
Wait, so tell me which free body diagram, which equation?
So free body diagram 1, you use
Free body diagram 1,
moments about A,
moments about A.
and then you use free body diagram.
Wait. If you did moments about A, you have one equation with 2 unknowns in it, right?
Yeah. So then
And
you
then
go
you do?
to free body diagram 3 to solve for CX.
Well, free body diagram 3 doesn't give me CX or CY. Give me this one.
Okay, yeah, that one.
Okay, so you did free body diagram 1, some of the moments about A, you got an equation with CX and CY and T. Then you went to then you went to free body diagram 2 and did what?
Solve for CX.
What equation did you do? Oh, sum of the forces in the X.
Yes.
And then 2 equations, 2 unknowns.
Yes.
Okay, so free body diagram 1, you did sum of the moments about A, and you got an equation with T and CX in it. And then you did free body diagram 2, and you did sum of the forces in the X equals 0, and you got a second equation with T and C, and you did systems of equations.
Yes.
Okay, Malcolm?
So what I did was I started with some free body diagram 3 and summed up the moments about A to solve for N.
Okay, sum of the moments about A, you get N, then?
Then in free body diagram 2, sum of the moments about C, you get T.
Good, okay. Okay, so option 3. Free body diagram 3, you did sum of the moments about A, and you got the normal. And then free body diagram 2, you did sum of moments about C, and you got T. Anybody else? Okay, so there are 3 options. Okay. All right. Do any of you look at the statics website at all?
Yes.
Somewhat? You know what I did? 3 days ago? I guess it was, no, Friday. On Friday, I updated the website with a bunch of stuff. Then you had said that there were some workshops missing.
Yeah.
Somebody said workshops, so I added that. I put the solutions to this quiz on the website to see if anybody looked at the website on the quizzes before I gave you the quiz. Anyway, so nobody saw it. Why would I do that? I don't know.
Do it again.
Okay,
Do you test it for doing them?
I don't know if I'll do it yet. Okay, so we're doing trusses, okay? So, everybody pull out, this is the sheet you have, right? And it has this on the back.